gentlemen, and good afternoon, everyone. And thanks for the opportunity to be here and talk to you about the robotics in tree crops and specifically on citrus. As mentioned, I worked for Citrus Research Center for 12 years, so citrus industry is one of my favorite industries to work with, just because I worked so long for them. So today, I'm going to talk to you about opportunity and challenges for robotic harvesting. And I'm going to come up with a quick introduction and talk about different techniques for harvesting and removing fruits. And then I'm going to give you a little bit the introduction about the components of a robotic system and talk about why it's so challenging to develop a robotic harvesting machine for tree crops. And I will talk about the existing opportunities that available right now for industry and summarize my thought with a quick summary of what I mentioned. So it's known for this group that labor is a major part of production, and there are lots of challenges for citrus industries right now in terms of production cost. And one of the major issues is about the labor harvesting cost is much. Labor availability, labor cost is a real issue right now for industry, and efficiency and all the issues that it brings up in terms of enabling us to be competitive with the foreign foreign markets. So I'm just going to start with this, which is in the left you will see a computer that was developed 50 years ago on the top left part, and a computer with significantly more power on the lower part of the left picture. And you will see that only in the 50 years how much improvement we had in the computer technology. And then on the right in comparison, you will see that how we harvest fruit in 1900 and how we harvest it today. So you'll see that significantly, maybe we have better ladders these days, but that's pretty much the same. That's how we do it right now. And then the question is why? Why we can have so much progress in one domain and one industry and not much, and why you don't see it translated to us for harvesting, and why we don't have a much better system, ways to harvest. So to start with, I'm going to give a little introduction about how we, in terms of basically fruit removal or mechanical harvesting automation, there are two, we can divide it into two parts. One part is fruit removal part, and then one part is a transportation part. And you can see that there's been significant improvement on the second part, which is fruit transportation part. Now we have platforms, harvest data. I'm going to talk about that a little bit. But we also have robots that can follow you and actually help you to carry the beans around. You will see that it's commercially available now for different industries, great industry using it. And all this basically helps to carry the fruits for you, so that the laborers focus just to fruit removal and not much time to transport the fruit around. So that part is pretty much mechanized, and there's lots of startups that are doing that. But the challenge still is on how to remove the fruit, right? And for that, we have basically three options. One is harvesting aid, and harvest aids. I'm going to talk about that. It's a platform that helps with the harvester to make them give access, easier access and safer access to the fruits. Alternative to that was a mass harvesting machine, which is, of course, I understand that in California we are not using that, of course, in this kind of, because our fresh market is not suitable for this kind of harvest. But I put this there because I spend a lot of time working on these machines, and the reason I'm bringing this up here is that to get, you know, in 2005, when I started working in the University of Florida, growers were very happy. They thought finally we have a good mass harvesting equipment, and Oxbow came up with this machines that was working really well. And if you look at how long it took for them to develop a machine that was working really well, it was more than 50 years of research and development until we got to a point that we had a machine exposed. I didn't put the videos here because it's not relevant to the flood of California, but the point I want to make is that these machines took them so long to just shake the tree, and you think this is the simplest thing to do, just shake the tree, get the fruit. And eventually the industry did that, and when I was there, these things started in 1999, and by 2008 or 9, about 12% of the Florida's fruit was harvested with this machine. The big one could harvest 353 per hour. So it was really improvement, and it was everybody excited about this machine. So and then we hit the greening came, and it changed everything. Now, as you know, right now, almost 0% is harvested with machines. It's all hand harvest. We're back to where it was before. So in spite of all those efforts, we didn't make it that way. And I want to say that robotic harvesting is our alternative choice, which still has its own challenges. So what are those challenges? Let me, before we get started talking about robotic harvesting, let's talk about Harvest A, because that's also another promising technology that has its own advantages, like enable to have a safe access to different parts. So probably safety was good, and also enabled some people with different ages still go and harvest. They don't need to be young to get to the top of the tree. But it came with its own disadvantages. One of them was that the speed of these machines, as you can see, there are 7 or 8 people on board and harvest. The speed of the harvest was directly related to the speed of the slowest person on that platform. So if somebody is slowly harvests, then the whole machine should wait till he finishes his part and then move forward. Another issue was that some of these machines needed a driver, so now you have extra cost of a driver, and also the fuel costs and other things would added to the system. So that was another disadvantage. Apple industry really liked this machine. I understand some people are using it. And the picture on the right side down part is the one that Oxbow developed this machine. And Oxbow was invested a lot of money developing a machine that's suitable for citrus industry, because a lot of fruits harvested is based on the number of fruit. The labor paid by the number of fruit they pick. So they put a lot of time and effort developing the system that were able to count the number of fruit as they got those holes and dropped the fruit. It was able to count who harvested how many, and they can get paid by that. So in spite of that, they decided not to continue this. They thought it's not, still is not good enough, and it's not able to for the industry to use it. And in Japan, the one on top right is they came up with the idea of why not we have one platform for one person. So this way, everybody can have his own platform, can go his own speed and all those things. Again, that's also add to the cost. And our bottom line is that all these things has to be cost effective for people to adapt these technologies. If it's not cost effective and it's not compete with the labor, it's not going to be adopted by growers. Oh, so let's go to say what's the robotics and what the options we have with robotic. So in order to develop a robot that harvests, we have to have 3 components. One is the platform. It's an autonomous platform that can move autonomously through the field and get to the different trees. The second component is the robotic arms, and the robotic arms should be able to reach different parts of the tree. So it has to be able to reach different parts. And then there's a part that harvests the fruits, which is basically a robotic hand. Crack and basically remove the fruit. And also, most importantly, you need to have a system that identifies the fruit and figure out where this arm needs to go. So the platform part of it is actually been a significant progress on that. Now we have a lot of autonomous platforms. So the platform part is technology is currently available. There are many companies who can offer and provide that. And this it's all good. So then we have to leave with 2 other options. One is, can we develop a good robotic arm and hand and a detection technique? So if we can solve those problems. So on the detection part, we can see that there are different options we have. We have RGB cameras, and those RGB cameras They are cheap, they are available, but the disadvantage of those is that they are very susceptible to the environmental condition, especially the light condition. So depending on, in order for the system to detect the fruit, it has to be calibrated and work for different environmental conditions, and that's one of the disadvantages. And then there are other options that came out, like thermal camera, that doesn't need has nothing to do with the light conditions, but it's only work very well at certain temperature conditions. When you see a difference between leaf temperature and fruit temperature, then you can identify the fruits very well. But that's limit the time that system works. Then we have time of flight cameras that can actually see a 3D vision, structure of the fruit. It can recognize the fruit, but they are also more expensive and the resolution is not good enough. So there are a lot of options out there, but each has its own advantage and disadvantage to use. Then the second question is that how the computer, let's say we have now good detection, we know the fruit, where the fruit is. The question is that how robot decide how to reach that point. Some of these things is so simple for a human to decide, I see the fruit, I'm going to grab and catch it. But for a machine to do that job, it's a lot more complicated. And for this particular case, then you have to come up with a collision-free path planning. So make sure that your hand or arm or robotic arms find a path that doesn't hit any branches and be able to get to the fruit and harvest the fruit. And then we get to the issue of removal. So we call it end effector or hand robotic arm, robotic hands. And of course, this part, the good news for citrus industry is that comparing to some other crops such as strawberry or peaches, citrus it can handle so much pressure, and it's not as susceptible to how you don't damage it as much as you can damage other crops. So this is the advantage of it. And but still, you need to develop this. You need to be able, and also you need to cut it at certain distance and under certain. You cannot just grab and pull it, right? It's not something that you cannot sell that fruit. But when you're able to, but here is the advantage of that. If you're able to touch the fruit, it gives you an opportunity to do some other measurement that I'm going to talk a little bit about it, that you cannot do it, or human cannot do that, but a machine can do it. I'm going to talk a little bit about that later. So I'm going to give you a little example of the, I'm going to give you a little example of, the strawberry is one of those industries that they invested on robotic harvesting, and there are many startup companies that actually focus on developing a robotic harvesting machine for strawberries. And there are actually, I put two companies' names, and you can see these are actually startups that they are trying to develop a machine. One of them is Agrobot, that is, still you have one operator sitting there just to monitor, but it's still harvest fruit. And then there's another one, Harvest Crew. They can harvest multiple rows at the same time, and one of the issues they have to deal with is that when you have multiple arm harvesting, if one of the arms fail and break down, then the whole machine breaks down because they cannot move forward to make sure that all of them work at the same time. So that's one of the issues they have. And I wanted to show you that if you look at the literature, you will see all kinds of machines they develop for strawberry. So if you look at the research part, you will see, my goodness, there are so many people working on this. But in fact, taking the idea from research and make sure it works under field conditions is significantly different. You can write a paper and just make it to work only for 2 hours and then collect your data and says, I'm done. But building a machine that works 8 hours a day for 2 months or 1 month, that's totally different story. And that's the challenge, how rugged you need to make those machines. And one thing you can see in this picture is that most of these things, they planted the strawberry in such a way that it's easier access to the machine to harvest. And that's something I want to bring it up because this is important that sometimes we need to also adjust our planting and tree shape to match the robots. It's very hard to just say, build us a machine that works for us under every condition, and that's not possible. So this is a project that was funded by NSF, and we are working on this project. And the idea here is that developing a simple, low-cost, agile machine that does one row at a time. So this is a collaboration with Washington State and University of Florida. We are building this machine for strawberry to harvest. And our job is to build actually the harvesting, and we are field testing this machine. But let's get to the citrus. And in citrus, it's interesting. Early effort actually started with citrus, and this is the work that was done in 1980, late 80s. I don't know if you can hear the voice on this. Well, the sound is not clear, but what they're trying to do is that they actually built a robot that was able to actually harvest fruit back late in late 80s. And the component of that machine still is the same thing. You know, you can see they have a 2D harvesting arm and a camera that was able to identify and detect the fruits. And then a platform. Of course, at the time they didn't have autonomous platform. They had somebody drive the system. But it shows the cameras and everything they use the same thing that we are using the same today. The only thing is that we have now much better cameras, we have much better computers, and we have much better robotic arms, and also mechanical components are all much better than what they use. But they were able to show that the concept how it works. Let's move on to the next one. This is another effort that again. Okay, let's move to this one. So this is again another effort that was the previous one. So is it done?
Do you want to play that video? No?
Yes, no, not this one, the next one.
Okay. The next one.
So this was another robotic arm that was designed again early 90s, and you can see it has a multiple degree of freedom and was able to actually harvest fruit. And again, it has all the detections and robotic arms and an end effector to remove the fruits. And you can see it was relatively fast for the technology they had back then. And I'm going to move to the next one. And the next one is the latest technology, which is Apple industry is now working on. So there are, as you know, Apple industry invests a lot of money on robotic harvesting. And one thing they did, and you can see here, they changed their planting. The trees they are using tall trellis. What they call it modern orchard design. That's what they call it. Which what they did is basically creating a 2D instead of a 3D dimension. They make it a wall of fruit. The wall of fruit. That fruits are kind of on a wall, and then that makes it much simpler for a robot to work because then there's only on one dimension. They only take C and this particular company, as you can see, they have multiple arms that start to harvesting. Can you run this video? So as you can see, there are like multiple arms that start harvesting. So one option for us, if you want to do this in citrus, and I'm not a horticulturist, I'm not sure if we can use this kind of training for trees so that we can make it easier for machine to harvest. But from what I heard from my colleagues in Washington State is that almost all new orchards are using this design. So they're all going to this design. And even almost 100% of apple goes to this. A big amount of cherries are also following this. And pearl is following with them. So this is what the industry started to do in Washington to make this system. And more, maybe if we can train a citrus this way, maybe that's an opportunity for us because we may be able, with some modification, use the existing this type of machines for citrus as well. But I also understand that this requires significant investment from the growers, and then the question is what to do with the existing tree. We can't just take them off. We have to, you have to find a way to harvest right now. And what I'm saying that if you want to look at the future, maybe it's something to consider. Can we have trees like this if you want to go that direction? Okay, so then in terms of performance of robotic harvesting, we are looking at three basic criteria: harvest success, harvest speed, and rate of damage. These are the three things that we would like to see. And I put some review from different literatures on different people come up with different numbers, and you can see there are two studies actually related to citrus. The harvest rate of the best one was like 3 fruits. I can't get this system, but 3 to 6 seconds per fruit. They're telling us that in order for robot to be able to harvest a human, they have to harvest 1 fruit per second. If you can harvest 1 fruit per second, then you can say we are competing with this. And of course, at the same time, we want to make sure we don't damage the fruits because that's important. And hopefully, citrus has less problem with that. And harvest success. And that's another thing that I hear from strawberry growers is that they say you need to have a very high success rate. Means that you have to be able to remove at least 90% of fruit because I don't want to have a crew and manage a crew and manage a robot at the same time. But if the robot cannot harvest good rate, then it's not really helping me because then I have to go back and then deal with the labor again. So you have to have a good success rate and good fruit removal in order for us to consider this. I'm not sure if that's true for citrus, but that's what I heard from strawberry growers. And then one thing I wanted to say is that these days the data is also playing an important role. Be able to collect data per trees, it helps us to better manage the crops, better manage the quality, and probably better things. This is the slide that I take from one of my colleagues in Japan. They were doing a study that they developed a sensor that can measure the sugar content, percent acidity, and defect, and some other factors. And they did it per tree. So the picture on the right shows that variation of yield for a given tree. What's the variation of the yield, fruit, and also fruit quality factors, like the sugar content and percent. And then if you can create a map like this that shows how much the variation you have, that could be a very helpful tool to better manage the crops. And this type of information can be collected with the robotic harvesting. That's one of the advantages of robotic harvesting is that eventually you are able to incorporate this kind of sensor on the robotic arm. So as you remove the fruit, you can also get this information. So all of a sudden you have significant amount of information per tree, which helps you to better manage that tree. Low yield, it could be related to stress, could be used for other things that we can help to better manage the fruits. So in summary, I wanted to say that the challenges that we have is that tree shapes and variability is really difficult to manage, and that's something we need to consider. It's for developing a robotic harvesting. Not 2 trees are the same, and developing a machine that can deal with all these variabilities is not a simple task. I mentioned environmental factor could affect the fruit quality. and detection techniques, and this is a challenge for us as well. But the opportunity is also coming with the robotic arm that, well, with the way that labor costs going, and we may need to start thinking about using this machine. Now we have much better cameras, much better computers that eventually, and also machine learning techniques, artificial intelligence really help us to significantly do a better job in fruit detection, and those technology now can be incorporated. So the technology is coming, and as eventually going to be able to help us, but it will be a while till we start to really see a good robotic harvesting machine. So with this, I'm just going to thank you all for the opportunity, and I'm open to any questions.